Hello, everyone. Welcome to our webinar today. I'm Nicole Rathi. I run AI for Manufacturing Canada. We are an industry association focused on accelerating technology adoption within Canadian manufacturing. We bring together experts like Remi and various other experts in AI for manufacturing. And so we are all really happy to have you join us today. In today's webinar, like I mentioned, we are joined by Remi Duquette, the VP of Innovation and Industrial AI at Maya HTT. So Remi has a wealth of knowledge deploying AI and ML solutions for Canadian manufacturing. And I am thrilled to have him join us today to share some of that expertise. Without further delay, I will pass it on to Remi to dive into today's webinar.
Thank you, Nicole. And it's a great pleasure and honor to be here again today. And I think, AI for manufacturing is a great way to share knowledge, AI use cases in manufacturing and from a business standpoint, how you apply it successfully, how it's adopted, and share the best practices as a community. So in the Q&A and webinar chat at some point, if you have questions along the way, just post your questions there and we'll have a nice 15 minutes at the end to answer some of those questions. And just for those of you who don't know Maya HTT, so we are essentially experts in engineering AI and operational technologies around industrial use cases and manufacturing use cases in particular. We've been in business for more than 40 years, so we've been around the block, as we say, and we have a use cases and benefits that we've seen adopted and successfully deployed from an AI perspective in manufacturing plants, in real operational plants. So today I will cover some of those use cases, give you some estimates, what you can expect as ROI benefits and what seems to be working, easier to deploy than other type of use cases. And hopefully that will inform your decisions as to how to proceed moving forward. And if you look at the last little slide on my HTT, we cover quite a wide range of technologies around manufacturing and digital transformation for plant manufacturers and industrial operations. So from very early on simulation of processes, of products, of manufacturing steps, all the way to applying AI, machine learning, deep learning, and doing advanced analytics on real operations and data, whether it's from telemetry, from sensors, from audio, from microphones, or from video, from thermal imaging cameras, 3D stereographic cameras, X-ray cameras, and other systems, or normal 2D cameras. So anything related to industrial applications is really what we cover. So today I will focus a lot of the talk around our clients' challenges, their transformation, the process to get there. It's of course, as we all know, a journey to get there. But to start from the use cases, really the business challenges that most manufacturers have. Probably seen, if you've attended some of my webinars in the past, this slide where I describe the return on investment on AI projects in manufacturing as deriving three main business value. Of course, you look at reducing your risks, augmenting your revenue, or reducing your cost. And depending on where you are on your maturity curve and your process of data-driven decisions and AI in manufacturing, you will probably focus on one of the three areas more than the others initially to get started. Of course, there's change management. People need to understand that they're not going to be replaced, but augmented by AI technologies today and for the foreseeable future. Manufacturing, a lot of people see it as there's two big segments of tasks when you look at very repetitive manual tasks. These typically can be a little bit more easy from an AI perspective to try and mimic and really focus on versus complex tasks, which really humans are great at. And, for the foreseeable future, we don't see, AI or robotic technology or automation get into those more complex tasks. So really, augmenting people is the name of the game, and to get to these different benefits, whether, quality, various things. We'll get to a nice acronym in the next slide on how Maya sees it, but it's really all around what we've now kind of deemed EPIQ-M. So you'll hear this acronym a lot from us anyway. And in the industry, I think it's pretty standard now that the business use cases that people will focus on AI perspective in manufacturing especially is related to 5 very key areas of your business, whether it's looking at energy efficiency improvements. So anything related to monitoring, your water, your consumption of gas, electric system and power, and all that for either sustainability or reducing, cost per product manufactured. All the energy umbrella is a big use case for sure to fine tune and reduce the cost of energy and your sustainability, improve your sustainability footprint from a generational perspective. As you get new, younger workers, clearly they will have an incentive and focus on some of these, green initiatives, and that can be a great way to initiate the change management process with them. Another one is productivity improvements. Anything related to your OEE calculations, your yield, your throughput, and really, at the end of the day, augmenting your cadence, your pace of production. So AI can do a lot of wonderful things there to reduce the startup kind of times and the raw material costs based on improving that productivity and the rate. While we'll see Q later for quality, while keeping quality level at the same level, despite, an increased throughput. The I is for inventory, anything related to your supply chain, right? So, sourcing raw materials and then delivering on time, or for your own clients. So that kind of forecasting improvements and understanding where and when you should source your material or from which supplier, and then again predicting better your lead time for your own product. That is where machine learning can do some wonderful things for you. Then Q, quality improvements from a quality standpoint, whether it's looking at machine vision or looking at the cross relation of multiple sensory inputs on the telemetry side to a quality defect that is recurring in your environment. So those are very interesting new ways where AI from a machine learning perspective can look at data in very complex and high number of data streams and help you get to a better place. So quality is definitely a nice place to start as well if you look at applying AI in manufacturing environment. And the last but not least, and the reason I put it last is because there's always a question on the amount of data you have for your preventive type of maintenance. So if you look at maintenance on any equipment that you have in your plant, you probably don't have a lot of failure modes are occurring in a let's say a high frequency. Otherwise, you probably wouldn't be in business. So the challenge often on the maintenance side, on the predictive maintenance side, is a force to have enough failure data or onset of failure data to be able to predict it. So that is where, from a Maya perspective, because of our physics understanding of the environment simulation side, this is where simulation, in a virtual world environment, where we can simulate some of your equipment and the processes that they undergo on a regular basis, on a 24/7 basis. we can create synthetic data, not necessarily on the failure itself, because that's nonlinear and take a lot of resources, compute is to mimic, but really to look at the onset of the failure mode. So as the telemetry changes, as it goes towards a failure mode, that typically we can simulate failure rapidly. So they can augment your normal operation data to generate proper machine learning algorithms that would be useful in practice and depict very early on some of the maintenance issues on some of your equipment. So in any case, those are the 5 areas that we always recommend to start, right? Look at your process, if you are very efficient from an energy standpoint, fine, right? From traditional techniques and statistical processing, if you have already fine-tuned everything, well, don't spend time there, right? Look at where you have heartburns and issues today. Where are your business issues today that remain to be tackled in? And those can be on the productivity side, on the inventory side, quality, maintenance, or energy, whatever mix it is. Make that list of problems you're having, and then let's sit down and see if we need to, if we can tackle them, and if it's the right project for you. So from an AI in manufacturing standpoint, once you've identified those business challenges that you have, and again, start with the challenges. Don't look at AI. AI comes, let's say, further down the stream. See what are those business challenges are. Once you've identified them, make a list of these small and big problems you're having. And then we can look with you and audit and see if you have the right data sources and the right sensors, right, to help use technologies, machine learning, and advanced technologies to be able to resolve those, in the right way with those sensors and that data. Sometimes there's gap in the sensors. Sometimes sensors have failed, right? The health check, sometimes there's some prerequisite that we need to put in place to make sure that from a data perspective, if you're going to become data-driven and leverage AI, which relies on data, you have to have a good foundation. So, don't put your head in the sand and pretend that everything is good in your environment, that all the data is beautiful and high quality and everything. No, just assume that you need to work there, right? And we're not thinking about going back 10 years of data and clean all of this. That would be, in my opinion, a waste of time. But when you look at moving forward, okay, what are the data pipeline do you need to put in place to make sure you really have clean data moving forward? That's really the key, right? Moving forward, and put the right data pipelines in place. So anyway, those are little tips and tricks from us after a lot of those projects. I'll get to the pedigree and what we've delivered in the past. So anyway, that's really where you start. And then you do some analytics, and then you get to deep learning and machine learning, beautiful models that will you move a little bit faster. Now, you hear a lot about me and Maya HTT. So from a, let's say, a background perspective, we've deployed more than 150 of those AI projects in manufacturing. Of the 150, there's about 50 or so that are in deep learning, so a little bit more advanced from an AI, algorithmic viewpoint, and 100 on basic machine learning, but still, depart from statistical process and traditional kind of control components that you probably rely on today. And the feed, the data that served those 150 plus projects are from 5.7 million different telemetry sensors. So real-time telemetry at different scales, millisecond, minute, depending on the use case, where we collect the data and created beautiful AI models, deep learning models to help in those 5 areas, right? Energy, productivity, quality, and maintenance, EPIQ-M, as we call it. And it doesn't really matter what technology stack you have really to get started. In here, what you've seen on the roadmap prioritization, so once you've identified those business use cases I was talking about before, then what we typically would do with you is, and you should probably take that if you don't leverage Maya HTT, that's fine, do it for yourself, right? Build yourself a little matrix of the business value and the AI readiness kind of columns and simply rank them between low, medium, and high, right? In terms of the value and the readiness. So do you have, a high business value? Have a time critical elements, something you need to resolve like ASAP because you keep stumbling and missing your deadlines. Do you have easy access to data to build those models? You have a good enough quantity of data. Think of maintenance, right? You have enough maintenance records to be able to reliable predictive maintenance models. Data quality, that's kind of a given that, and I'm not talking about, a little bit of variant and around the telemetry and various noise in the telemetry. We're talking about you often have a rag that is put on a sensor, and then the sensor data itself is no longer shouldn't be used. So for the quality of that data. Is it reliable data? Is it data that can be used and correlated with a specific at a specific time? And I talk about time because if you're in discrete manufacturing, things will happen in sequence, but sometimes in certain stations, you'll move a product up front instead. And so now the data related to that product needs to also follow and move ahead. So there's all sorts of intricacies in terms of the data, wrangling the data transformation that needs to be done right so that your AI models, right, are built with the right data associated with the right quality of the product or the productivity of that related to that product. So, sensitivity is important to take into account. Data variance, people don't talk enough about variance. If you, in most, industrial and manufacturing environment, have been called in a lot of the time, people look at variance, in terms of they do only small incremental improvements in, continuous improvement type of program. So when you look at manufacturing, that's fine, that's great, right? You're incrementally getting better over a long period of time. That's what you want. From a data perspective, this is terrible, right? You have very little or no variance across time and across long periods of time. So that essentially is a problem for building deep learning and machine learning model. A lot of failures that you're going to hear in the news, things, in terms of failed AI projects in manufacturing are related to the fact that there was not enough variance for the machine learning model to learn anything of your process. So that's where you need to, understand the variance that's in the data or the lack thereof, and see how you're going to generate enough of that variance so that we can build beautiful model with you or for you in there. And then ease of data generation, whether it's the real-time telemetry that you can generate or synthetic data with the onset of failure modes, for instance, for various equipment that Maya could deliver for you. And then you look at the effort estimate. Again, low, medium, high. Very simple, right? Low, medium, high. Data engineering effort, AI effort. This is where, from a Maya HTT perspective, we can inform you as to how much effort it will be for a specific project. And guide you along the way. Once you've evaluated all this, you're going to have like these points, right? So low, medium, high for the business value and the time to implement. I've just synthesized it in 2 axes here. But really what you're looking at is, a map of where your quick wins will be from a project standpoint, which you should tackle first, right? And typically we try and one that's, start with one that's the closest to the left, right? In terms of, the highest on the left of the time to implement that has the highest value. Then, from a business use case value, often the quick wins, very high value with no time to implement are rare. So you'll typically have to rely on good bets like here, whether it's product quality issues that you want to resolve, can be a quick bet there. The second one, first time yield success rate, improvement, reduce and performance variability. So these are typically not necessarily low-hanging fruits, but they're like low time of implementation because you do have a lot of to begin with, right? Everyone measures quality, right? Otherwise, you're probably not going to be in business. So if you measure quality, it means we can probably, adjust a few things and help it and move forward a little bit and nudge it in the right direction as an AI in manufacturing project. So just again, very briefly, typically it can be in-house or you can leverage partners like Maya HTT to deliver some of that functionality. Sorry, I skipped one slide here. So typically we'll start a consultative approach to look at what you have, right? Your business use cases, see you have the data, if the data is aligned, if you need any technological stack improvement to get to an adopted proof of value project. And then we will deliver with you or for you the sensor fusion, dashboarding, and the AI models. And we have multidisciplinary teams to do this very deep bench of industrial expertise that can go across, right, from your Industry 4.0 type of audit all the way to the delivery of ML first, machine learning project, all the way to then maintaining those ML projects, ML algorithms over time, because there will be drift, there will be new seasonal effect that we're not necessarily taking into account in the first model delivery, and all this needs to be maintained and upgraded. And as you change machines, change various things, you're going to have to inform the AI model that you've made those change, and so you can retrain it and kind of map the called the ML operations or ML ops. You'll hear a lot of that terminology now that machine learning is deployed and working. It's like anything else, you need to make sure you upgrade it and update it over time. Piece of technology that lives and breathes. We talk a lot about the data and the data sources. So I'll show you in a few minutes the quite a few use cases from our client journeys. But from a data source perspective, a lot of people are quite asking what kind of data do I need to have? So of course you can have traditional sensors, traditional time series type of data. You can use synthetic simulation data. So in this case, you see a tire manufacturing process where we can, not just simulate the manufacturing process, but also simulate various PLC controllers and various settings. And then, put a real edge device, a physical edge device in that mix. So, kind of hardware in the loop and test that everything will work well before you commission your components. And then you can see in here all the simulated data that you can have. So these are the various components of the simulation type of data that you have that you can access. On the audio side, a lot of people, when we talk about maintenance, they go straight away to vibration sensors and a lot of vibration data. And vibration data is great, but the challenge with vibration is typically very close to failure once you get there. So one thing that we've heard a lot from people from walking their shop floor is, oh, I'm hearing something wrong, and there must be something wrong with that machine. So we typically will go with an audio and acoustic microphone setting and microphone arrays that you deploy very cheaply, right? And then you can connect it very quickly and go in real time as fast Fourier transform, so you get the frequency of your environment. And if you abstract the noise of the environment, which is the white noise of the environment is roughly constant, or it's just in slow easily subtracted, then you're left with really the frequencies of vibration of the machines themselves. And when you see shifts frequencies, then they will typically indicate a problem, right? It could be just misalignments, slow misalignments in your belt, or in the level of oil going down and it's changing the noise of the machine, or there's a little bit of metal chunks that are getting into the gear. So that there all these different types of noise will eventually lead to a failure mode, are great indicators and great predictive indicators of a problem. So this is, when I get to towards predictive maintenance, those are the real interesting bits that you want to collect. So we've done a lot of that component generation on the acoustic side, transfer frequency domain. In the video is a sensor. So, we all think of videos and people walking around and these little pose models, as we call them in AI, that everyone can deploy fairly easily. But really, video can be used as a sensor in the sense of, if you use a thermal imaging camera, you can see how the temperature and the profile of temperature are changing over time. And that indication of over time is typically where you can get some additional value out of the data that is being generated by and we've used 3D stereographic cameras, thermal imaging cameras, and of course the 2D normal video streams to generate very interesting insights. Other type of data from a technical documentation and troubleshooting guide perspective was made now kind of available, if you will, for technicians to augment themselves by virtue of large language models. So you can think of ChatGPT, but a local version of it that has learned only from your data and that's private to you, where you can essentially leverage those large language models to your shop floor workers on the manufacturing side. So AI for manufacturing, large language models can be used, right, for having a chat-based kind of troubleshooting guide where new workers can actually chat against your own documentation and very specific settings of machines and the way it was configured and deployed and commissioned within your plant, and help you with those kinds of information. So now, talk a lot about the business use case, the data. So let's see some real examples of how this process ends up. So here is an example in discrete manufacturing. So lithium batteries for electric cars, 10 different stages of manufacturing. And again, when you think of the little wafers that go into a pack with the electronics, those are the different stages of the manufacturing from a discrete perspective. The challenge that people get there is there's a very difficult relationship and associativity between the data and the actual product, what ends up in the huge pack, the battery pack at the end of the. So in this case here, what we did is look at that kind of associativity between data and the problems that they were having, and built a lot of deep neural networks to look at the causal effect to the variability of their batteries. So from the best battery versus the worst battery, there was a huge gap between the two. So when you go into sale support, then you get a very high variance of challenges. So to reduce that, let's say, variability, they wanted to make sure they couldn't get that on control. Assuming my audio is still good.
I just cut out there for a minute, but it's back now.
Okay, perfect. So hopefully it's gonna stay on. Had these on and off here, but anyway. Let's see. So yeah, so there you go. So from a prediction of the variability is what was really important in their case. So to reduce that variability, we built deep neural network, use the data that was sequenced in the right fashion and labeled and associated to the right product. And you can imagine a wafer that was looked bad to a technician, they put it aside. other wafers move forward, and they, after looking at it, is like, oh, okay, it's going to be fine. They put it back in the line. So now you have shifted the whole data that's related to each of the wafer because you've moved the wafer physically in the sequence of production. So those are the kinds of issues that, you know, will trip you. When we talk about quality of data, it can be related to just that, to the association between the data and the physical world. If there's not a easy relationship, one-to-one relationship, then you need to put in place the processes to make sure it's in place, right? So that you can actually use deep learning in there. I mentioned at some point, you know, Maya HTT, understanding the physics behind the data. In the lithium manufacturing, that became pretty key in the cooling time. So when you look at lithium and how it evolves over time, of course, our client was tracking, you know, temperature is a function of time, discharge is a function of time, and everything is a function of time. But when you looked at, you know, applying machine learning, deep learning on these time series data, it actually gave pretty subpar results. I mean, the improvements were not that great. But then, you know, when we took a step back and look at the data, you know, from a physics understanding, we know that the lithium will settle as a function of temperature, not a function of time, right? So all of a sudden, just by changing the properties and making a table as a function of the temperature, yeah, the temperature does decrease over time in their cooling process, but it was an indirect and, you know, non-linear really relationship there. So, you know, by just flipping the switch on the table and mapping it to a temperature dependent, all of a sudden we got beautiful results, right? And so when you see the 99.5% accuracy rate, so those are the kinds of levels that you only reach if you fully understand the physics behind the data. Without that flip of the, you know, from time series to temperature dependency series, then we were at 68%, not 99, right? So there's a huge gap often, just the way you look at the data and the dependency on the data and the pricing for manufacturers. So that's very important to keep in mind. Another on the pulp and paper. So now we go to a completely different process. So a continuous, you know, ongoing manufacturing process. So you drop the pulp, you put the resin in the reservoir and everything, and then you flip the switch and you turn on the machines and it goes. And then at the end, you end up with a huge roll of paper. So in their case, they had about, I don't know, 600 different sensors along the food chain, and they wanted to put the quality parameters of the paper. They have about 20 different quality parameters. Some of them could only be tested in a lab, so they would literally cut a little bit of paper, bring it to the lab, and send it to the control room, you know, 15, 20 minutes later, and then, you know, half an hour later, you get a better batch of paper being delivered. So there's a lot of waste, material wasted, and you know, cold startup time could be fairly significant. So were the challenges that we were trying to tackle. And based on, you know, the deep learning being able to predict what the actual, you know, 20 parameters. We focused initially on a few of the key ones, of course, the critical ones, and by being able to predict them and not have to rely on the lab measurement, to every, you know, 5 minutes maybe send, you know, tips and tricks to the control room so they can be moved. Of course, from a human perspective, these machines have big levers and stuff, so, you know, it couldn't be automated. We couldn't those tips and tricks to the automation system. There were, you know, a lot of manual buttons and stuff to push on. So the technicians felt very augmented in this case because they were key at on some of these tips and tricks to improve the production. So that was quite an interesting project. Here, what you'll see is manufacturing of those small, low volume, high quality parts. So again, a very different process, composite layup with robotic arms that often the aerospace and defense industry will use. So in those cases, In this case, they relied mostly initially only on the robotic image to figure out, what was the defect and, what defects came up in some of those domes. And instead of having to send it back to the engineering department so they can come visually inspect the defect and then clear them or not, then we were able to essentially have the technician pause the program and look right away at before there's a buildup and so that engineers not have to come in and really look at the bigger problem later on after you have 40 layers of composite tape being put on the here. So those are all very interesting, use case that you can leverage in your manufacturing. And again, you see like quality and productivity improvements that are fairly low-hanging fruit and first good projects to start with, and those are the results here. This one's different in terms of the using AI for reinforcement learning for control perspective. So a lot of people use PID controllers. They're very reliable, very robust. They never fail, and that's why they're everywhere. But the challenge with PID controls, they're always catching up to the signal. So they really are always in a kind of a stable. They always kind of catch up, but you're always in an unstable position in many ways. So in this case here, you can see the PID controller kind of regime before by AI-based reinforcement learning. And you can see it's very noisy, but now it's noisy to the point where there's a lot of, the mechanical fluctuations, in this case on the control volume and configuration side is huge, right? It's fluctuating so much. You can see how it would impart, damage potentially over and increase the fatigue life of the mechanical components that have to follow this the signal. Versus once it's enabled, you can see how very narrowly you can control your process in a much better way with the blue line orange becoming very, very much narrow in nature. So there's a lot less mechanical fluctuation. So there's less fatigue on all the parts and the mechanical components. So now all of a sudden, the pumps and the things that are around that process are not strained as much, right? So you actually save a lot of money just because you don't have to do as regular maintenance as before because your mechanical parts are not strained as much in this process. That was kind of a very interesting component. A lot of people in batch manufacturing will look at downtime. There's a lot of conveyor belts in the batch manufacturing process. So here we were looking at 40 plus conveyor motors that were driving everything in the process itself. And in the end, again, I talked a little bit about the this before. Initially, they wanted to put a bunch of vibration sensors, and we said, whoa, time out. Before you get to that, like vibration sensors, in this case, especially for those conveyors, once you get to vibration mode, your failure, window and time of reaction time is very narrow. So you're not going to be able to do a lot of predictive maintenance because you're going to just like be firefighting, when it happens, maybe a few minutes or an hour earlier, but you're still going to be firefighting. So you're not saving that much. And this, what we did is say, okay, let's put some microphones and let's see if we can abstract the noise, the white noise around your environment, and see if the frequency shifts. And lo and behold, right on the conveyor motors, you hear the shift in frequency and much earlier. Now you're talking a few days prior to a failure mode. And in those cases, then you have time, in between shift, in between, a batch that you want to try or change the batch to a different product type. then you can go and repair and change the motor that is about to fail and cause you downtime. So to avoid the downtime. So in this case, you see the unplanned downtime per year, and the failure mode failure avoidance improvement by 1/3 of those failures were avoided by this very simple and low-cost acoustic solution. Here you see executable win in the casting furnace, so saving energy on the casting side for large metal transformation type of processes. And again, we go back to the EPIQ-M. So all of these follow the same rule. We've looked at all their processes and the various projects they wanted to potentially tackle with AI technologies. And we found that this was a very low-hanging fruit for them too, because they were already tracking their energy. They already knew it was one of the most expensive component from an operation standpoint for these furnaces. So by the casting side and reducing the amount of energy even by 3% was a huge improvement. Plus, we helped them with some of the data engineering side so they can do more analytics in much less time than they were before. So giving them more access to the data that was collected in their environment. Here's using, I spoke a lot about the 3D stereographic camera. So this is just an example. It's one of the tech that we use, for figuring out the 3D path of different things. In this case, with forklift example, for security type of use cases. This is a little bit more advanced, right? So I don't think I would recommend it as a first AI in manufacturing type of project, but it's an example of the safety and security side where you can use stereographic cameras to essentially remove blind spots in some of your plants. So if there's a lot of things around or things moving in 3 dimensions that could potentially hurt people, then having those 3D stereographic cameras nowadays can make a lot of sense. So here is on the operational optimization. We've presented quite a bit with publicly with CL over the years, and we help them go from pen paper to analytics and AI eventually. So in this case here, what we see is their operations, and really what people don't understand is why am showing a marine vessel and a AI for manufacturing kind of discussion. These are mini floating factories. If you look at the underbelly, they have all these conveyor belts that are moving the dried goods outside of their plant and moving it back inside and making sure that you're tracking the components within the belly of that ship. So it's really a mini floating factory that they have, and that's one of their business advantages, that they don't need anything at shore load and unload the cargo. So you think of salt and powdery metals and that kind of stuff. So anything in powder form is what they move around the planet. They have, I think, more than 60 vessels around the planet that do these types of deliveries. And it was interesting to look at, again, anomaly detection, energy efficiency. These all come back to be, the most, from a business standpoint, still things that are of value to end customers, where traditional technique has brought them to a certain level. And now with AI technology, we can go to another level of accuracy and value, really. So when you look at this, here's more metallic part, traditional machining. When you look at custom parts machining, really, that's what this client was looking at. Initially, we didn't think we could do a lot with them because the parts are so custom. But then when we look at the actual process of the machining, the sequencing of machining on the CAM computer-aided manufacturing side, we saw that they were generating these G code that is then used and loaded on the machine that will then drill the holes and do all the, the making of the part and remove the metal down to the part that in 3D that you want to manufacture. And that process repetitive, right? There were a lot of these various steps that were the same across all the parts, even if the parts themselves were very different. So again, when you look at the data quantity, you sometimes to go one level deeper to understand if yes or no you can tackle this problem with AI technology or not. And in case, well, after a second look, we realized that yes, it could be leveraged, and we could leverage deep learning in their case to predict the cost of a system part that they had never manufactured before. So those are, again, time savings in the costing side, slightly different than the traditional, let's say, AI use case in manufacturing. I thought it would be still relevant. So we'll get to the Q&A, but one of my key recommendation for you is whenever you get to apply AI in manufacturing, I think you need to go through it with a step-by-step approach. And as I said early on, the consultative approach of looking at your business use cases and make sure that you don't skip that beat on the step of properly auditing what you can and cannot do in your environment is key. And then you do a minimum viable, but a real end-to-end implementation of a small project. And then you can scale all plants and processes. So on that, Nicole, I think we're at the Q&A session.
Awesome. Perfect. And thank you for that webinar, Remi. It was very, awesome to see the real life's case studies mixed with the actual technical knowledge. We do have 2 questions here for you.
Okay.
We'll start off with, what technologies are you/Maya delivering all these different components of the E2E solution?
So whenever we look at the technological stack, of course, if the client has standardized on a specific stack, we will typically try and leverage that stack. So I'm going to mention the obvious in North America, whether you have a Siemens and Aviva, or others, we'll try and leverage what they have from an OT perspective, certainly. Operational technology for OT, and then see what the IT layers are. If you're going to build your own AI models, right? Are you on Azure? Are you on AWS or other platforms? So Maya, we have experts in all of those IT and OT platforms, right, to help the client decide. And sometimes we will identify gaps, right? We will essentially recommend that, yeah, you could do it with your existing stack, right? Here are the pros and cons of going down that route versus be doing something a lot better with another stack. But if you don't have the resources to maintain that stack, then you have other problems, right? So again, we're not there to impose a hardware or software solution. We are there to enable AI in manufacturing. And our expertise is really to make sure that no matter what the stack is, that we, the customer gets the value. But yes, the obvious Siemens, Aviva, Azure technology stacks are certainly things that we have deployed as part of those 150 projects that we would recommend in components of those solutions.
For sure. And just, I think Thomas kind of gave you a reply in the Q&A box here. As well, more about being an expert on all. Maya, I feel like, and you can build on this, I'm sure, works really hard to kind of customize, from what I've seen, 2 different solutions. So to Thomas's second kind of question there on.
Follow up, I can certainly say, Thomas, that yeah, you're correct, except in the last decade, we've also acquired talent on our side based on their different technological stack expertise. So, we're roughly 200 plus at Maya HTT. So we have the luxury of delivering those AI and manufacturing solutions to multiple clients, and so we can maintain the expert. We're not experts in all technologies, I can do that much, but I would say the core ones, certainly that we face in those 150 projects, we master quite well. Yeah.
Awesome. And moving on to the next question here as well. What computer vision / object recognition frameworks / and models have you used for forklift stereograph application? Can you dive into that a little more?
Yeah, for the forklift example, so I don't know if you're familiar with them, but Stereolabs have these Z cameras. So the ones that we use are the Z2Eyes cameras, which are fairly let's say agnostic on the back end solution software. Use it for within whichever stack, Azure or other stack that you want to deploy open source components, whether it's with PyTorch or TensorFlow for the machine of things. But yeah, the framework is their proprietary SDK from Stereolab that we've used, and I recommend you have a look at them. They have a lot of and examples, and it's been used in agricultural environments, in shop floor environments. So they're very good. Yeah, very graphic camera to start at least. Yeah.
Definitely.
There are many other options, but
okay, next question here is what is the success rate for AI-based implementations targeting manufacturers in the energy and efficiency improvements?
So energy and efficiency improvements, I would say some of the highest rate, right? So when you look at the five, across the five, that's why I put it, actually, we came up with this acronym of EPIQ-M with E first, and because it's actually quite high, because a lot of the small changes in forecasting and improvement accuracy on the forecasting side will yield fairly interesting efficiency improvements. So even if you have, I'm going to call it modest goals in your energy improvement, that's probably also part of, you have to define success rate. But if any small improvements yield a big return on the business side, that's where you need to wait first. But if that's the case, then the return will be very high, and the success rate is very high in those projects. So Alex, we can continue the discussion after if that does not answer your question, but I would say more than 98% to 97% of our list, I would have to look at all of the ones that's some that I know we've deployed, and I know that some of our clients deployed on their own thereafter, because often we want have our clients become master on destiny, right? Our goal is not to stick there forever, right? We want to move to the next higher, more complex kind of challenge that they have, and enable them to deliver similar or other types of projects by themselves.
Excellent. And I think you may have hinted to some answers to this next question as well, Remi, in your last answer. But what are the most common mistakes you've seen when within AI manufacturing initiatives? You may have touched on some, but
I've touched on some, so maybe I and certainly common mistakes would be to focus first on the technology, right, and apply technology without looking at the kind of business use case and what would actually yield important benefits for the company. and then thereafter not or skipping or skimming the data aspect and the sensor, that are needed to make you successful. Often we get, involved a little bit late in some projects, and we see that simply, one of the key critical sensor that would yield, let's say that would be related to a specific failure mode is not even there. So, some of those mistakes sometimes are the low-hanging fruit to fix too, which is ironic. Or at least that's what we've seen often is simple steps that are skipped. But yeah, the common mistakes are certainly in overlooking or not spending enough, a little bit of the right amount of time. I'm not saying to spend a huge amount of time on the data, but the data engineering for the AI use case that you're going to tackle, right? I'm not talking about cleaning the whole and create pipeline all the data streams that you have in your plan. That's a waste of time. But before you launch into machine learning and building AI models, why don't you make sure you operationalize the data pipelines first, so that you get the same data that the AI will then consume, right? Because often a simple mistake that we see, a common mistake, is simply people will take offline a huge amount of data, right? They'll send that to a data science team. The data science team will transform the data a million ways. They will create a beautiful AI model that has an F1 score like you wouldn't believe, but then as they redeploy it in real time, then they forget a few of the 100 million transformations and data operations that they've done before ingestion into the AI model that they trained that full data set. Well, guess what? Things will happen in operations. A rag will be put on a sensor. There will be things that will derail the whole AI model. And the basic one is simply the data is not the same because it's not transformed the same way. Normalization of data is something that most, if not all, of data scientists would do, right, to get going. And well, that means the normalization needs to be done in real time as well on the input side, right? And do you normalize on a fixed value? Do you normalize on another? Anyway, so there's a lot of technical difficulty that are common, very simple mistake on the data side that need to be looked at. So I think, if I kind of summarize, missing some key sensors or data entry as a cause and effect relationship with what the AI model is supposed to is a key one. Not spending enough time on the data pipeline and putting the real data pipeline in operations before you launch into a huge AI effort would be a good way to avoid these basic common mistakes.
Awesome. Perfect. And perfect timing there. We might just open, if anybody else has any more questions, feel free to put them in the chat right now, as we're running out of time here. But just as we wait for that last question to come in, if there is anything, thank you all so much for coming today and attending our webinar. So great to have so many of you, ask some questions and get involved. I will be sharing the recorded version of this throughout our ecosystem, and all of you will get a copy of it. Feel free to share it with your ecosystem as well. And thank you so much to Remi for joining us today and sharing so much of your knowledge.
Thank you, Nicole. Always a pleasure to be with the AI for M. More people, whether with or without Maya HTT, please go ahead and start leveraging AI in your manufacturing environment. It is definitely going to be helpful and will benefit from it.
Awesome. Perfect. And just the last question here, the best way to connect from this webinar for other questions, I will pass along contact information in the email shortly after this, and we can keep the conversation going. Awesome. Thank you all so much for joining us today.
Thank you, Nicole, for hosting.